Okay, so I've just created a little flip chart here with representative problems. This is if all this stuff, if you feel good about all these, you're going to do really well on this test. Okay, so first things first. Yeah, that's good. Thank you. So we're supposed to use factoring to solve the polynomial equation. Okay? So we got to factor this as much as we can. What do we always try to do first when we're factoring? Yeah, we want to factor out a GCF, don't we? Okay, so let's do that. If we factor out, what could I factor out here? What could I factor out, everybody? 2x squared, okay. So if I factor out a 2x squared, what's going to be left behind? Well, I could just divide each of these by 2x squared to see. 2x to the fourth divided by 2x squared is x squared. Negative 72x squared divided by 2x squared is negative 36. Okay, good. So now we've got this thing factored enough. If we want to, we could. We have the option here. You know, you have choices. You could factor the blue again. So I get 2x squared times x squared minus 36 factors into what? Good. X plus 6 and x minus 6, because it's a difference of squares pattern. And the whole thing is equal to 0. So then would you guys agree that my zeros are going to be the 0 of the first factor, 2 times what squared is 0? 0. The 0 of the factor x plus 6 is negative 6. And the 0 of the factor x minus 6 is x equals 6, right? Now we can get it that way, or the way I would probably do this, to me I think it's always a little bit easier. I don't really have to go that extra step with factoring. I could just set this quadratic factor equal to 0 and solve too. That just seems like slightly easier, but it's up to you. So x squared minus 36 I said equal to 0, which means x squared equals 36. So x is plus or minus 6. Either way you slice it, my solutions are 0, 6, and negative 6. Okay, give me thumbs. How we doing? Okay, good. All right. How about one like this? Solve the polynomial equation. Okay, well, what do we always have to do first? Set it equal to 0, right? I got to push everything over to the left side this time because I want my biggest power of x to have a positive coefficient. So we'll push this guy over there, and we get the equation 4x to the fourth minus 4,000x equals 0. Okay, we got it in standard form. Now, what do we always try to do first once I get it in standard form? Factor out a GCF. Yeah, what's the biggest thing I could undistribute here? 4x. Good. Okay, if I factor out a 4x, what's left behind if I factor out a 4x? 4x times what is 4x to the fourth? X cubed, okay. And then 4,000x divided by 4x. Everybody agree that's just 1,000? Okay. Now the red factor's done, right? But the blue factor, I have to keep going because it's not quadratic or linear. It's cubic, right? So I can't set it equal to 0 and solve until I get all the factors down to at least quadratic, right? So what do I have to do with this one? What's the pattern I would use? Difference of cubes. And 1,000 is what cubed? 10. Okay, so I could replace the 1,000 with a 10 cubed. And then what's my difference of cubes pattern? What's that look like? If I have an a cubed minus b cubed. Here, I'll tell you what, I'll put it up here so it's kind of out of the way. a cubed minus b cubed. How does that factor? I get a binomial and a trinomial. The terms in the binomial are a and b. The terms in the trinomial are all the different ways I could multiply together a and b. So I could do a times a times b times b, right? What are the signs? A cubed minus b cubed, what signs go where? What's that sign? Minus, plus, and the last one's always plus. Good. Okay, so then we can factor using that pattern, right? This is going to break up into a minus b times a squared plus ab plus b squared. And I've still got my 4x out front, and it's equal to 0, correct? Everybody good with that? Okay, now I'm good. Now I've got all my factors, red, blue, and green are all quadratic or smaller. So I can set them equal to 0 and solve, right? First one's easy. What's the 0 of the first factor? 0. Second one is equally easy. The 0 of the second factor is 10. Third one's a little trickier. How am I going to do the third one? Should I try to factor? No, never's going to work, right? Because it's an irreducible quadratic when I use my difference of cubes pattern or my sum of cubes pattern. So what do I do to get the solutions here? Quadratic formula, for sure. So x would equal negative b plus or minus the square root of b squared would be 100 minus 4 times 1 times 100, all divided by 2 times 1 is 2, right? Okay, so that gives me x equals, let's go ahead and split the denominator, right? And we're going to get negative 10 over 2 plus or minus the square root of 100 minus 400. What's that? Square root of what then? Negative 300. Okay, so we just have to simplify the square root of negative 300. What's the square root of 300 going to be? 10 radical 3, isn't it? Now, how come? If we look at couples go out, singles stay in, let's go back to that. So if I do a 300, isn't that just going to be 100 times 3, and the 100 gives us a couple of 10s? Right? So I get a couple 10s and a single 3. So I'm getting x equals negative 5 plus or minus the square root of 300 becomes a 10 times the square root of 3 over 2. And what happens to the negative inside the square root? Becomes an I outside. And so my final answers then, would be x equals negative 5 plus or minus 10 over 2 is 5, right? So I get 5 times the square root of 3 times I. So there's my other two complex conjugate zeros. Okay? I got 4. 2, 3, 4. And that's what I should have gotten, right? 4. Okay, give me thumbs. We good? Okay. Okay, how about this one? What do I'm supposed to find all the solutions. What do I have to do first? Set it equal to 0. Okay, so we'll push the 16 over to the left side, and I'm going to get x to the 4th minus 16 equals 0, right? It's in standard form. Now I got to factor the left side. Can I set it equal to 0 and solve? I can't. How come? That's That's a fourth degree polynomial, right? I can only set quadratic factors or linear factors equal to 0 to solve. So I'm not there yet. I have to be able to break this apart into quadratic factors or smaller. What's the pattern I could use here? Difference of squares, right? I could write this as what squared minus what squared? X to the fourth is what squared again? Okay, so x squared squared minus 4 squared. So by my difference of squares pattern, what's that going to break into then? A squared minus b squared factors into what? Hey, let's write it down. A squared minus b squared factors into what? A minus b, a plus b, either order, doesn't matter, right? So a is x squared and b is 4, right? Okay, so then isn't that going to factor into x squared minus 4 times x squared plus 4? Everybody good? Give me thumbs. Okay, and that's all equal to 0. So what are my options now? Could I factor the green further? Thumbs up or thumbs down? I could, using a difference of squares. Do I have to? No. I could also, because it's quadratic, I could just set it equal to 0 and solve. Take your pick. I'm just going to set it equal to 0 and solve. So we get the equation x squared minus 4 equals 0, right? So x squared equals 4. So x equals what then? Plus or minus the square root of 4. So plus or minus 2. There's 2 solutions. How about over here? If I set this equal to 0, x squared plus 4 equals 0. I subtract 4 from each side. X squared equals negative 4. I square root both sides. So I get x equals, because I square rooted both sides, I need my plus or minus. What is the square root of negative 4? 2i. Good. So there are my 4 solutions. 2, negative 2, 2i, negative 2i. Okay, give me thumbs. Good? Okay. Okay, how about this one? And by the way, when you see any questions on the test that say use a graphing calculator, table, or graph, no, you can't. There's no graphing calculators available. You can only use the scientific, right? Okay, so we're going to solve this equation. Now, what do we have to do first? Set it to 0. So we're going to put it in standard form. We're going to write the polynomial equation equal to 0. So that means I'm going to move these terms over. Terms on the right, I'm going to move over to the left, agreed? Because we have x cubed is the biggest power of x, and we want that positive. So what does that make our equation? You guys, in standard form, tell me what the polynomial on the left side of the equal sign is going to be in the proper order. 25x cubed. So plus, I'm going to add it to the other side, so plus 100x squared. Good, minus 9x minus 36 equals 0. Good, okay? So now we've got a polynomial equation. The polynomial on the left side has 4 terms. So what's our strategy for factoring that? Grouping, good. Okay, so we're going to break this thing up then. We're going to break this thing up into 2 groups separated by a plus sign. Okay? First group. Gavin, what can I factor out? What's my GCF of the first group here?
Like the left side?
Yeah.
5x squared.
Okay, I can maybe even go a little further. 25x squared, good. Okay, so the GCF, 25x squared. What's left behind if I undistribute a 25x squared? X plus 4. Good. Okay, so what has to be the same in group 2 then? X plus 4. Okay, can I make that work? Is there something I could undistribute to make that work? Ah, minus 9. Good. So I could undistribute a minus 9. And now, which of the two factors, blue or red, is going to be factored out or undistributed from each group? I can only undistribute like factors, same factors. So the blue one, right? Good. The blue one is going to get yanked out front. Okay, what's left behind when I undistribute the blue factor, the binomial? Okay, 25x squared plus negative 9, which is the same thing as minus 9, right? Everybody agree? Equals 0. Now we're good, right? Look, we've got this down to where it's each of the factors is quadratic or smaller. So I could set them equal to 0 and solve. Last time, we just set the quadratic equal to 0 and solve. So how about this time we break it up into using difference of squares? Okay. So what would the two terms be for this to look like a difference of squares? What's the first thing that's being squared? 5x. Okay, so that looks like the quantity 5x squared minus what squared? 3. Okay. So then, hey, what's up? Yeah.
What's your next period?
My next period is Algebra 1. Algebra 2, I mean.
Do you have time to help us?
Right after 8th period, I could.
After 8th period?
Yeah,
Okay.
yeah. Come right back and start, yeah. Okay, so then, we've got this x plus 4 out front. How about this difference of squares? What's that going to factor into? What's one of the factors that's going to break into my difference of squares? Okay, so we got a 5x plus 3 and and 5x minus 3. And now we can just set each of those equal to 0 and solve, right? To get the zeros. So first one's pretty obvious. Negative 4. Second one you can do in your head. If I set that equal to 0 and solve, what am I going to get? Negative 3/5. I'm going to subtract the 3 to the other side and divide by 5. And the third option? Positive 3/5. Everybody agree? Okay. Give me thumbs. Good? All right. Good stuff. I like it. Okay, what about this? Same kind of thing, right? It's already almost in standard form. I just have to rearrange the terms a little bit, don't I? So they go in descending order of powers of y. So all I'd really have to do here is just rearrange those so we have, oops. So we have y cubed first, then would come the y squared term, then comes the y term, then comes the constant. Okay, factor by grouping again, right? Everybody agree? 4 terms. Okay, so if we factor by grouping, got my first group. What's the GCF of the first group? Y squared, leaving me behind with what? Y minus 4. Everybody agree? Got to have what in group 2 then? What could I factor out to make that happen? 4. So just like before, we're going to yank the common factor out front, the binomial. So we get y minus 4. Now what's left behind? Y squared plus 4. Okay, this time I can't factor the red one because it would be a sum of squares, which is not a pattern, right? So I have no option but to set these equal to 0 and solve. First one, pretty simple, y equals 4. Second one, if I set it equal to 0, my two steps would be to subtract 4 and square root, right? So we get y squared equals negative 4 if I square root both sides. Don't I just get y equals plus or minus 2i? Everybody agree? Okay, so there are my three solutions to that guy. Okay? Okay, same kind of, different this time. This is a trinomial, right? So for a trinomial, I want to try to factor this like a basic trinomial if I can. What are the values of a, b, and c in this trinomial? A is what? 1. What's b? Negative 7. C is 6. Okay, so I want to be able to factor this if I can, like a regular trinomial. What would the magic numbers be that multiply to 6 and add to negative 7? Say it again. Negative 6, negative 1. Yeah, good. Everybody agree? Negative 6, negative 1. Okay. So negative 6, negative 1. Okay. And the question, though, is what would have to go there and there for this thing to FOIL out properly? It's not a p. It's a p squared, isn't it? Because when I distribute, I need to get p to the 4th instead of p squared. Everybody see that? Give me thumbs on that part. We good? Okay. Okay. You don't have to write it this way, but at least in your mind, you're thinking of this. These are my values of a, b, and c, and so I want to write my trinomial out as a times something squared plus b times something. So that looks like 1 times something squared minus 7 times something plus 6, right? Well, that's only going to work if the somethings are x squareds this time, right? Okay, which is also why we're getting, not x is p squareds. Do you have something for me?
No, I was just wondering, can I come in during your prep tomorrow?
Sure. Yeah, that's fine. Or
Just for help on the...
yeah, how about, can you come right after school today?
I can't.
Okay, yeah.
Does that work?
Either that or I'll get you for advisory.
Okay.
One or the other. Okay, yeah. Okay, so these should be, man, I'm in demand here. So these are both going to be p squareds then, right? Okay, so I got this thing factored. Now I could factor further with the p squared minus 1, but I don't have to now. I'm just trying to solve this, so they're quadratic. So why don't I set each one equal to 0 and solve? So p squared minus 6 equals 0. Add 6 to both sides and square root. So does everybody agree I'm just going to get p equals plus or minus the square root of 6? Good? Okay. Or if I do the other side over here, p squared minus 1 equals 0. So p squared equals 1. So p equals plus or minus the square root of 1, which is 1. So those are my solutions. Plus or minus the square root of 6 and plus or minus 1. I got 4, which is what I needed. Okay, give me thumbs. Good. Okay. Okay, synthetic division. Piece of cake, right? Super easy stuff. Synthetic division. We can just build our bracket. what goes in the first row of my synthetic bracket here? What is it again? Okay, coefficients. So I got 2, 13, 0. Good, because look, there's a 0x term that we didn't write, a missing term. So we need a 0. And then the last one, 19. And then wherever the constant is, the remainder box just goes below the constant. Okay, now what's the number that goes out front? -2, not 2, right? Because we want the 0 of x plus 2, which is -2. Okay, what do I do once I get my synthetic bracket all set up? Good, I drop the 2 down below the bracket. Anytime a number appears below the bracket, what do? Multiply and add. Opposite of long division. You subtract with long division. You do the opposite or add with synthetic division. So 13 plus -4 is 9 times -2 is -18. Right? Did I do that right? So I get -18. -18 times -2 is 36. And so I actually get a number in the remainder box of 55. Now what happens if I had nothing in the remainder box? Well, then I get a really simple answer. I don't even have to add the remainder term in my answer. Right? Everybody see that? Okay, so what's my answer look like? Well, how do we interpret this? Remember, the numbers next to the remainder box underneath the bracket are the coefficients of the polynomial part of my answer. This is the constant, so this must be the coefficient of x. This must be the coefficient of x squared, and if there were more numbers, they'd be coefficient of x cubed, x to the 4th, etc. Right? So then what's our answer? Okay, well, we're going to get the polynomial part, which we get from the yellow numbers below the bracket, right? So this is the, oops. So this is the yellow part on our work, plus what's the remainder term look like? Yeah, and the remainder is what remains over the denominator. So we're going to get our 55 is what remains over x plus 2. Okay? Good? 1 to 5? Okay? Good? Okay, quick long division one. Now, I can't do synthetic division here because the bottom is too complicated. The denominator is too complicated. I can only do synthetic division when the denominator is really simple, when it's x plus a number or x minus a number, right? Okay, so I got to use long division here, unfortunately. So there's my division bracket. What goes inside the division bracket? The top. Yeah. Okay, so that gives us 9y cubed plus 12y squared minus 12y minus 19. What goes out front? Okay, good. The denominator. Now, we didn't have any missing terms, but remember, I have to have a column of y in this case. I have to have a column for each power of y, right? So if I were missing a term, I'd have to have a 0 coefficient in there, inside the division brackets. Outside, it doesn't matter. So outside, we've got 3y squared minus 4. Okay, now remember what we're trying to do is we're asking how many times does the leading term outside divide into the leading term inside, right? In other words, what's 9y cubed divided by 3y squared? And the answer is 3y. So the first term in my answer is 3y, right? Okay, whenever I get a number on top, I have to multiply by whatever's out front, and that means I have to distribute it to each term, not just the first term. I have to distribute it to the whole thing. That's the multiplication part, and then subtract, just like regular long division. So 3y times 3y squared is 9y cubed. 3y times negative 4 is minus 12y. And then I'm going to subtract vertically, right? So look what happens. The y cubes cancel. The 12y squared I bring straight down because I'm not subtracting anything from it. Okay, now be real careful with this. What's negative 12y minus negative 12y? No. It's 0 because I'm subtracting a negative means I'm adding, right? Does that make sense? So negative 12y plus 12y, those guys cancel. And then I bring down the minus 19. Okay, everybody good? And we go again. Okay, so now we're just going to ask, how many times does 3y squared divide into 12y squared? And because the power of y that we got after subtracting is at least as great as the power of y in our the leading term of the denominator, right? We can keep going. 3y squared divides into 12y squared how many times? Well, let's see. 12y squared divided by 3y squared is what? 4. Yeah, okay. So we get plus 4. There's the second term of our answer. Okay? But now we've got to see if we have a remainder. If there's no remainder, we're done, right? Okay, so if we distribute the 4, 4 times 3y squared is 12y squared. 4 times negative 4 is negative 16. And we're going to subtract vertically. And look what happens. The 12y squareds cancel. But negative 19 minus 16, did we? Yep, yeah, we're good. Negative 19 minus negative 16, that's plus 16. Doesn't that give us a remainder of negative 3? Okay. So then what's the remainder term going to look like in our answer? It's going to be plus negative 3 divided by y squared minus 4. Now, how come they have a minus there? Okay, we could write it either way. We could write this as (3y plus 4 plus negative 3 divided by 3y squared minus 4. But adding a negative is just like subtracting a positive, isn't it? Everybody see that? So if I wanted to, I could just write that as minus positive 3 on the top. Everybody good? Either way would be fine. Okay, give me 1 to 5. Okay, there's a little bit of a process there on the long division ones. So that might be an area to get just a little bit of extra practice tonight. Okay, what about stuff like this? Use synthetic division and the remainder theorem to find the indicated function value. All they want you to do is find f of 2. What could I do? Well, I could just plug 2 in for x and get an answer, and it'd be fine. I could have done that first day of school, and you guys would have been fine with this problem. If you want to, you can use the shortcut, though, which is the synthetic substitution shortcut, which just tells us that synthetic division is also synthetic substitution. Whatever you get in the remainder box is going to be the value of the function when we plug a 2 into it, right? So we would just get this then. The 2 goes out front. I get coefficients 3, negative 11, 4, negative 3. I drop this guy down. 3 times 2 is 6, plus negative 11 is negative 5, times 2 is negative 10, plus 4 is negative 6. 2 times negative 6 is negative 12, plus negative 3 is negative 15. So what's the answer? What's the answer? Negative 15. So f of 2 equals negative 15. And again, I could get that by just plugging 2 into each of those terms and simplifying without even using synthetic substitution if I want to, right? Okay. How about this? Factor f of x into linear factors given that k is a 0 of f of x. Well, look what they're telling us. They're telling us that negative 2 is a 0 of f of x. So then what must be a factor of f of x? If negative 2 is a 0, what's the factor that goes with that? What's it going to be? X plus 2. X minus negative 2, which is x plus 2, right? So we know right away that f of x is going to equal, it's going to equal, let's do it this way. It's going to equal x plus 2 squared times something that we don't know, right? X plus 2 squared times, let's just call it g of x, right? Because I'm going to get, the multiplicity is 2, right? So I'm getting the factor x plus 2 shows up twice, so it's squared. X plus 2 squared times g of x is this whole big long quartic factor, right? So I just need to figure out then, okay, x plus 2 squared is being multiplied by what? Well, I could find out by dividing, couldn't I? Right? I could just divide the big quartic polynomial by x plus 2 squared. I got two options. I could FOIL out x plus 2 squared and get x squared plus 4x plus 4 and do the division in one step using long division. Or my strong preference would be, let's use synthetic division twice, right? Because we know that negative 2 is a 0 twice, so it's got to go in evenly 2 times. Much easier in my opinion, okay? So let's do that. This is kind of where last example we did the other day was one like this. Let's make our synthetic bracket. Okay, what are the coefficients? Well, there they are, right? It's going to be 1, 3, negative 12, negative 52, and negative 48, right? Everybody see why? Because it's just, all we're doing here is just dividing each side by x plus 2 squared to figure out what the other factor is of the big quartic polynomial. Okay, give me thumbs on that. Everybody good with the strategy? Okay. So I'm dividing by, my 0 is negative 2. And what do I know has to go in the remainder box if negative 2 is a 0? 0. That has to be 0, right? Because we're told negative 2 is a 0 of this polynomial. If it doesn't work, either the problem is screwed up or you made a little mistake. Okay, so what's that give us then? So we're going to get, I bring the 1 down. 1 times negative 2 is negative 2 plus 3 is 1 times negative 2 is negative 2 plus negative 12 is negative 14 times negative 2 is positive 28 plus negative 52 is negative 24 times negative 2 is positive 48. So when I add those up, I get 0. Okay, so negative 2 worked once, but it's guaranteed to work twice. So let's just go again. Right now we've got this new synthetic division problem, and we can divide this whole thing by negative 2 again, because the multiplicity is 2 of that 0. Okay, give me thumbs on that. Does that make sense? Okay. So we bring the 1 down. 1 times negative 2 is negative 2. plus 1 is negative 1 times negative 2 is positive 2. If I add those up, I get negative 12. Negative 2 times negative 12 is positive 24. And sure enough, those add to 0 like they had to, right? Okay, so what's that tell us then? That tells us that this other factor, the constant is negative 12. I've got a negative 1x, and I've got a positive 1x squared, right? Everybody get that? So then, whoops. So what is that going to factor into? I know that the big quartic is equal to x plus 2 squared times g of x, which is that, right? Isn't that whole thing down there g of x? Right, everybody see that? G of x is x squared minus x minus 12. Can I factor that a little bit more? Yeah, I can find magic numbers, can't I? Doesn't that split up into x minus 4 times x plus 3? Everybody agree? Okay, so then my final answer is going to look like that, isn't it? Okay, good? Okay. Okay, same kind of thing here. If we're supposed to solve this, are we out of here in 1 minute? Okay, so we've got just a couple pages left. Really, I've only got one more tough problem. So why don't we'll wrap these up tomorrow, and then you guys can just start testing after that. Got a couple more to get through. So was that helpful or unnecessary? Helpful? Okay.